Okay, so in our abstract topic of the ambiguous case of the law of signs, we are given three pieces of information. Okay, so no matter whether it's A or B or C, right, your angles A, B, or C, or if they use some random other letters, you will always be given three pieces of information. Number one, you know an angle. Okay, they have to give you one angle. And then you're going to know the side across from that angle, right? This is the opposite side. You will know those. They might have the same letter, right? Capital A versus lowercase a, because they have to give you letters so you know what side you're looking at. And then the other information will be some other side, right? An adjacent side. An adjacent side is always the one that makes up your angle. Okay, so this is the information that we're given: an opposite side, an adjacent side, and an angle. And you can always draw your triangle with this orientation. So the key to figuring out how many triangles you can make comes from calculating the height of your triangle. Okay, and the height is always perpendicular to the base, which is amazing. So we're going to look at this triangle right here that I am highlighting in purple. Okay, this is a right triangle, so normal trig is applicable, right? It applies. So the H is the opposite side for my purple triangle, and the adjacent or the blue circle is your hypotenuse for the purple triangle. Okay, is that understood? Right? They're different sides for your greater triangle, but for the purple right triangle, the H is the opposite side, and the adjacent is the hypotenuse, right? It's the hypotenuse side. I just called it adjacent. That's its name. So I have a sine relationship, which is why it's the law of sines, by the way, one of the reasons. So if I solve this for H, I figure that the height of the triangle is whatever the adjacent side is times the sine of that angle. So it's a pretty quick calculation, and that tells us some things. Okay, that tells us a couple of things. Number one, if the height is greater than the opposite side. Okay, if the height of your triangle is greater than the opposite side. In that case, we're not going to have any triangles, okay? Because what's going to happen is, here's the base of our triangle, there's our angle. Okay, if the height is greater than the opposite side, like this, then this is just going to swing back and forth here and never actually be able to reach this side down here, right? It's not long enough to reach. So if the height is greater than the opposite side, you're not going to have any triangles be able to be formed whatsoever. Okay, so whatever information they give you, if the height that you calculate, which is the adjacent side times the sine, if this calculation is greater than the opposite side length, you have no triangles. Okay, so that's one thing that we can do straight away. What happens if we have one triangle? Well, if the height is equal to the opposite side, right? If the height is equal to the opposite side, then of course we have a right triangle. Okay, because this is the angle and this is the adjacent side right there. Okay, or if the opposite side is significantly greater than, or even a little bit greater than the adjacent side. If the opposite side of your triangle is greater than the adjacent side, then you can only have one triangle be formed. Okay, so this is simply looking at the information that you're giving and making a value statement. Which one is greater? Is the opposite side greater than the adjacent side or not? And then here is the ambiguous case, when we can have two triangles be formed. Okay, so that means that the adjacent side is the biggest. Okay, so the opposite side is less than the adjacent side, but the opposite side is greater than the height. Okay, if the opposite side is greater than the height, but the opposite side is less than the adjacent side, then we're going to have two triangles, right? And that's the case where this side can swing over here, and we can still have our side-side angle, but we have two triangles formed with that information. Okay, so that's our first thing, is to decide how many triangles we actually need to look for. And then actually calculating them can be the second difficult part. Okay, so in general, that's what we're going to do. We are going to test to see how does the height compare to your sides. Okay, solve the triangle if possible, it says. So it might not be possible, right? 0 triangles means it's not possible. So let's first label our triangle. Okay, so I would say always draw it with the same orientation. Okay, always draw it like this. Okay, and we're going to put the angle that you're given in the lower left corner. Right? The consistency is sometimes key to all of mathematics, but especially when we're trying to make general statements. So if that is side A, or angle A, that means little side A is across from it, and we're going to put side B here. So angle B goes there, and angle C goes at the top. And little side C is here. Okay, remember that the angles and your sides are across from each other that have the same letter. Capital letters are angles, lowercase letters are sides, and they're across. Okay, so we are given that this is 32 degrees. We're given side A is 30, and we're given side B is 18. Okay, so for our situation, A is the opposite side, and B is the adjacent side, okay, to our given angle. Right, not that it's a right triangle, but that it's across from it. Across means opposite. So let's look. Is the opposite side greater than the adjacent side? Yes, 30 is clearly bigger than 18. So that's going to tell me, right, because of the opposite side being greater than the adjacent side, that we're only looking to solve one triangle. Okay, so the law of sines, we're going to only have to use it once, and we're going to be done. Okay, so it follows this rule that if the opposite side is greater than the adjacent side for your triangle, then we only have one triangle to solve. And we're going to solve that triangle using the law of sines. Okay, so we have the ratio of 30 over the sine of 32 equals the other side that we know, 18 over the sine of the angle across from it, which is B. Okay, so we're using the law of sines in order to solve our triangle because we know two sides and not the middle angle. So from our algebra that we talked about before, in fact, it was yesterday, we're going to cross multiply, right, and solve this equation for B. So if you're unfamiliar with how we solve these equations, let's go over that. So we cross multiply. So 30 times the sine of angle B equals 18 times the sine of 32. Because we cross multiply whenever we want to solve a proportion or two equal fractions, we cross multiply. Our next algebra step would say divide both sides by 30, okay, which gets rid of that one. So then the sine of angle B equals this fraction, and I'm not going to put it in my calculator just yet. I'm going to keep it here. And then our last step to solving this is to move our sine to the other side. And we do that by taking the inverse, okay? Which is good because if we want to find an angle, taking the inverse is exactly the procedure that we need to do. So inverse sine of this fraction is how we're going to calculate the measure of our angle. Okay, so now we go to our calculator and we put this calculation in there. And we find 18.5391. So I'm just going to round to one decimal place, but 18.5391 is what my calculator says. So whatever your teacher wants you to round to that. Okay, so there's angle B, and now angle C is pretty straightforward. All we have to do to find angle C is subtract the other two angles from 180. Okay, so we had an angle A of 32, and we have an angle B of 18.5. So 180 minus 32 minus 18.5 is an angle of 129.5 degrees. So it looks like we have an obtuse triangle. And then our last thing to do is figure out what our side C is. So no, that's not right. I need to go back and do my law of sines, which says, let's see, 30 over sine 32, right? I always use my given ratio. 30 over sine 32 equals side C over the sine of the angle I just calculated, 129.5. Okay, so once we find one angle using the law of sines, we find our third angle with geometry, and then we find our missing side, once again, by doing the law of sines. So 30 times the sine of 129.5 divided by the sine of 32 gives me a side length of 43.684 when I round to 3 decimal places. Okay, so once we decide that there is one triangle, we find all of the missing information, which are your 2 angles and your missing third side. Okay, but that's not what this lesson is about. This one is about how many triangles do we have. Let's go back to our second example. Here we have something called angle B. So remember, we're going to put in the same orientation that we always do for these type of problems. So now this angle is called B. So this is little side B across. B is your opposite side, and C is your adjacent side. So we're going to put C here, which is 35, and we're going to put B, which is 20, and angle B is 49. Okay, so finishing this out, that means angle C is here, angle A is up top, and little side A is there. Okay, so notice it's the same basic positioning, only we've just rearranged our letters. Okay, so let's see. Is the opposite side greater than the adjacent side? No. So here the adjacent side is greater than the opposite side, which leads us to believe that this might be a 2 triangle situation. So now we just have to calculate the height of our triangle to see whether it's a 1 triangle, a 2 triangle, or a no triangle. So there's the height. Remember, the height is always the adjacent side, which in this case is 35, right? This side times the sine of your angle. Okay, that's how we calculate the height every time. Is the adjacent side of your triangle times the sine of the angle. So 35 times the sine of 49 degrees. The height is 26.4148. 26.4148. So then how does the height compare to the opposite side? The height here is greater than the opposite side, which means we have 0 triangles possible. And if we have 0 triangles, we don't need to calculate any because there's not one. Okay, it's this case here where your opposite side is not long enough and the height is preventing it from touching that third side of your triangle. Okay, so it did make the fact that the opposite side was less than the adjacent side, but when we calculated the height, we found that the height is greater than the opposite side. And you can't have a triangle if this is too long, right? This is like a swing where the height of the swing better be greater than the radius, or you can't actually swing. Okay, so if the height is greater than the opposite side, there are no triangles to be found. Which leads me to believe, since these are notes, that this one's going to be a 2 triangle situation. So let's verify that that actually is the case. So this is going to be angle C in the lower left-hand corner of 42 degrees. Side C is opposite. Okay, side C is opposite, and side B, which is 28, is going to be your adjacent side. Okay, so we can fill in angle B is in the lower right corner, angle A is at top, and little a is going to be the side on the bottom, the way that we have oriented our triangle. So to verify that we have two triangles, let's calculate the height. Okay, so the height is the adjacent side, which is 28, times the sine of 42. 28 sines of 42 degrees is 18.7357. Okay, so our height is less than the opposite side. So sure enough, the height is less than the opposite side, which is less than the adjacent side. So we're going to have two triangles to calculate. Okay, so we do the first one using the law of sines. So I'm going to pause the recording and do all the work. So in 3 seconds, you're going to see all the work pop up. Here's all the stuff. Okay, so the important angle is angle B, right? This is the first thing that we do with the law of sines, is we calculate our angle across our opposite angle from their side that you have. Okay. The other triangle, if you set up the same equation, will always give you 58.4 degrees. Right? We can't expect to get a second angle using the same exact number. So now we're going to have to use our brain for a little bit, okay? Which is the hard part, I know. Okay? So here's what happens. We have an acute triangle as your original triangle. Okay, where this is 42 degrees and this was what side? This is 28 and this is 22. Okay. So what happens is, if I were to keep this as a 22 degree length, it would swing over here like this. Okay. So the triangle that we're going to, our second triangle, right, and this comes completely from your noggin, right? Nobody is ever going to do this. You have to understand that your second triangle is going to be an obtuse angle, or an obtuse triangle. Okay? It will be always, just because of the way that these work out. So our first calculation said this angle is 58.4 degrees. So let's take a run back to geometry for a second. Okay? If this side is 22, did we change the length of this side? Right? We have not. We're keeping it side-side angle, which means this side is also 22. So what kind of a triangle is this leftover part of our triangle? This is an isosceles triangle. And as an isosceles triangle, if your two sides are equal, that means your base angles are also equal. So if this was angle B that you calculated a second ago as 58.4, that means this part is also 58.4. Well, also back to geometry. Okay, there's a lot of geometry here, I know. This is a straight angle, right? This is a straight line. And these are a linear pair. And what do a linear pair always add up to? 180 degrees. So when we're going to calculate our second B angle, right, which is this one right here, this is our second B angle for our second triangle. This is 180 degrees minus whatever it was that we calculated the first time. Always. It is always that, because of this isosceles triangle and linear pair business. So we don't ever use the law of sines to calculate our second triangle angle. It will always give you 58.4 degrees, no matter what. It can't give you anything greater than that. So we have to understand this idea, right? And it's an idea. This is completely mathematically abstract, that your second triangle is an obtuse triangle that is nestled inside of this isosceles triangle. So you subtract the angle that you calculated a minute ago, which was angle B, from 180. Okay, this is the key to doing your second triangle, is knowing that your second angle B is 180 degrees minus the first one that you calculated. Because after that, we go back to geometry and our three angles add up to 180. So angle C is 121.6. Sorry, let's do it this way. 180 minus 121.6 minus 42. Sorry, this is not angle C, is it? This is angle A. Sorry, angle A. Because we were given angle C. I apologize. Angle A is this. 180 minus 121.6 minus 42. And it should be a tiny angle. 16.4 degrees. Okay, if you look at your picture that we drew, this is a pretty tiny angle. So you should be expecting that to be tiny. So then our third thing would be to find out what side A is. And we go back to your standard law of sines over the sine of 16.4 now. Okay, so this is the hard part about having two triangles and the ambiguous case of the law of sines, is how do we calculate our second triangle, right? How do we calculate the stuff for this triangle? Well, you use whatever angle you found the first time, angle B in this case, and you subtract it from 180. And that sounds like the bell. So I'm going to end this here. Maybe I'll make another video just about this part. All right, hopefully that helps. Goodbye.